Hello, algebra students. Today I want to talk to you about the turning points in polynomial functions. So first of all, what is a turning point in a graph? If you have a turning point in a graph, it means you were going down, the graph was going down, and all of a sudden I'm going up. It means you turned around. So I'm going up, and now I'm going down. That's a turning point. So here we have 1, 2 turning points. Here we're going down, and now I'm going up. I'm going up, and now I'm going down. I'm going down, and now I'm going up. This one has 3 turning points. So name how many turning points. Be careful. So here I'm going up, and then I'm going down. 1. Be careful of this next one. I'm going up really fast. I'm still going up. I'm just going up slowly, and I'm still going up. At no point did you change direction. So be careful. That's a pivot. It's not a turning point. So this one has no turning points. So be careful of that one. Now here's our rule. If your degree, so remember the degree of a polynomial is the highest power on the variable for the term with the highest degree on that variable. That degree on that variable is the degree of the polynomial. And if your degree is n, the most number of turning points your graph's going to have is 1 less than that. So if you have a polynomial with degree 7, the most times it can turn is 6 times. If you have a polynomial of degree 3, the most turning points that graph will have is 2. 3 minus 1 is 2. So if your degree is 3, 3 minus 1 is 2. But I want to think more deeply about this. That is the most possible turning point you could have, but you could have less. So if your degree is 3, we know from the previous video about end behavior that if your degree is odd, your ends will be at odds with each other. They'll either go up, down, or down, up. Let's think about that. If you start, let's say up, and you're going down and you turn once, and then you turn a second time, that would be the right end behavior for an odd degree. But what would happen if you started up and you turned only once? Then your end behavior would be even. That wouldn't work. At most 2, and the numbers that are smaller are 2, 1, 0. But if it only had 1 turning point, then the end behavior would be either up, up, or down, down. So we could never say that a degree 3 polynomial had just 1 turning point. But we could say that a degree 3 polynomial could have 2 turning points and have the right end behavior, or it could have no turning points and just have a pivot, or just be a pivot. If it was degree 3, we know it wouldn't be linear. And so here's a way to think about it to go back and forth. If you're given the polynomial function and you can see what degree it is, you subtract 1 and you know the most possible number of turning points. You can't have more than that, but you could have less than that for turning points. But on the other hand, what if you're given the graph and you can see with your eyeballs how many turning points there are? Then you can figure out how many turning points plus 1 tells you that the degree has to be at least that number. It could be higher, but it has to be at least that degree. So if I know the degree, I can figure out the maximum possible turning points. Could be less, but can't be more. If I see the number of turning points because I see the graph, then I know that I add 1 to see the minimum possible degree. It's at least that degree. Could be higher, but it's at least that. So given these graphs, count how many turning points and figure out what the least possible degree has to be of the polynomial that generated that graph. Going down, now I'm going up, now I'm going down. 2 turning points. Oops. Here, going down, up, down, up, 3 turning points. So if I have 2 turning points, add 1, the least possible degree is 3. If I have 3 turning points, add 1, the least possible degree is 4. Try it again. Practice on your own paper and then press play. I have one turning point, add one, the least possible degree is 2. Careful, this has a pivot. It doesn't have any turning points. If I add one though, be careful. The least possible degree can't be 1 because if the degree was 1, it would be linear. And we see that's not a line, that's a wiggle. It's not a line. So we know the least possible degree actually given this graph would be 3. And so with that, I will leave you with that about turning points. I'll leave you with this cute puppy and wish you a great day.